Hey GED students, welcome to virtual GED class. We are continuing our progression through data analysis. I want to do a specific kind of data display today known as a box and whisker plot. So good news and bad news. I guess the bad news is this is kind of a different kind of a graph than most people are used to. They haven't really seen it before, so I want to get a chance to introduce it to you because it is supposedly on the list of graphs that could come up on the GED. That being said, I myself have not heard of a particular instance where students see a graph like that. So we're not only going to focus on like how to make the graphs today, but we're also going to look at these box and whisker plots, like just interpreting data. So we'll focus on those word problem skills that we need regardless of the type of graph that we're looking at here. So and I warned my students, we've got students here with us today, Maricela and Serenity, warned them that I am sick. So you've been warned as well. So bear with me as we sniffle through this topic here. Again, this new kind of graph is called a box and whisker plot, which seems like a really weird name, I know. But you'll see as soon as we see one why it's called a box and whisker plot. Basically, it looks like a box with a little line in the middle, with these kind of lines coming out from either side that are the whiskers. And notice what I subtitled this. I called this visualizing data distribution. So what a box and whisker plot allows you to do is see how the data is distributed at a glance. Let's go ahead and explore this topic. So two things we have to remember in order to learn this new thing, or to understand what we're learning. We need to remember what a range of a data set and a median of a data set are. So let's see if we remember. Okay, ladies, do you remember what a range is? What is the range of a data set? Range is when we forget a lot because it's not one of those M ones, right? We're used to the measures of central tendency, the mean, median, and mode. It often gets taught with those, but range isn't actually a measure of central tendency. We had said that range was a measure of spread. I wonder if that jogs your memory at all. If I say that it's a measure of spread, would that give you a hint as to what range is?
Distance between like couple of numbers, I'm thinking.
There it is. It's how far spread out our data is. So it is the distance between a couple of numbers, or distance difference. So it means the same thing in math. It'd be the difference between the maximum value and the minimum value. That's how spread out your data is. So exactly, it's the difference between the max and min value. And a lot of people just memorize this as high minus low. Yes, high minus low would be one way to find the difference between the maximum and minimum values. And of course, those would have to be the maximum and minimum values of the data set. I do have lovely students who just pick up random numbers from anywhere and go, but this is the lowest number I found. Yeah, it better be in the data set. Okay. So it's a difference between the maximum and minimum values of the data set. Okay, cool. So we remember that. Why don't we go ahead and find the range of our ages right now, just so everybody could have their memory jogged. So I think I'm the oldest in the group. I would have the maximum age. I'm 39. So if I wanted to find the difference between the maximum and the minimum, who's the youngest in the group? I think it might be you, Serenity. How old are you?
Yeah, 25.
25, okay. So between the three of us here, and Maricela, I'm just assuming you fall in the middle, okay? If I'm the maximum age and Serenity's the minimum age, then the difference between our ages would be 14 years. So if the data set is our ages, we've got a range of 14 years. On the other hand, does anybody remember what a median is? A median is one of those M ones. It's one of the measures of central tendency. Anybody remember which one it is?
It's like the middle number of a number line.
It's the middle number of an ordered set. Absolutely. The middle number in an ordered data set. The data has got to be in order. So little boring with the three of our ages, but we would have to order our ages. So we already said Serenity was the youngest and I'm the oldest, and Maricela, now you have to tell me how old you are right here on YouTube, or you have to lie.
32.
So just as I suspected, Maricela fits right in the middle. So one off the front, one off the back, really easy, boring set here. The median of our ages would be 32, because that is the middlemost number. So what a box and whiskers plot allows you to do is it allows you to visualize these two concepts. So we know what they are numerically right now. We know how to find the number of the range and the number that represents the median, but this particular graph is going to show you these two things in a picture. Let's go on and look at a picture of one of these graphs here. Okay, so I have a little generic unlabeled box and whiskers plot to the right here, and you're going to notice a few important features that I want you to see. Okay, so one thing that you should notice here is that we should have some kind of a number line. Now, most of the time these number lines are horizontal, but I've actually seen ones where it's vertical as well. It could happen, okay? But this particular one, we've got this horizontal number line, and we have a box and whiskers plot above it. So it tells us what these different things represent, okay? The box and whiskers plots always consist of this box. So we can see the box here first, okay, with the line in the middle, okay? And that's why I was saying that we had a visual representation of the median. That line in the middle of the box right there, that marks the median of your set. That's not the only thing we have. So that was this one, a visual representation of median. You also see on a box and whiskers plot the maximum and minimum. The maximum and minimum are the ends of those whiskers. So on this particular one, it's dots. I've seen other ones where it's lines. It doesn't matter, but we do have a min value and a max value. Okay, so we have the maximum and minimum values represented on this. And because we can see our minimum and maximum, that means that we're going to be able to see the distance between them. I love it that Serenity described the range as the distance between these two numbers, the max and min. I mean, yes, distance, mathematically we call it difference, but in this case, because it's a picture, I would call it distance. It's that same idea. So this entire length of this line represents the range. Short line, small range. If that was really, really big, I'd have a large range. Okay, wonderful. So I get that visual representation of the range. And then one other thing you're going to see is just the way this is divvied up. Basically, it divides our data into 4 continuous groups. Okay, they are this one, this one, this one, and this one. My data has been divided into 4 groups by those 4 sectionings on the box and whisker plots. And we're going to be referring to those as quartiles. It's interesting because I'm going to use the word quartile 2 ways. I'm going to use it to describe these groups, but I'm also going to use it to describe the boundaries between these groups. So, but yes, it breaks it into 4 equal pieces. It breaks it into quarters. So now let's go look specifically at a box and whisker plot with some specific data. So I introduced a totally new concept to you now known as quartiles. We're going to be talking about quartiles. And this is the part that I said, Serenity, don't focus on memorizing what a quartile is. I'll be surprised if you get it on your test. But I just need to give you enough basic information here that as I go through this, you know, you'll know what I'm talking about. Okay.
Right.
But if I expected quartiles to show up, it'd be on the science test, and you already passed yours. Okay. So first of all, what am I talking about now when I say quartiles? When I talk about quartiles, I'm going to be referring to the values, so some number that divide a list of number into. I said quartiles again, so isn't that weird? And that's how I said it was kind of meaning into, you know, you can use it 2 different ways, but just cross that out right there. How about the values that divide a list of number into quarters? So this is so similar to something we've done before. This is similar to median, because when we did the median, we took this ordered list, right? And we did the median, kind of broke that list in half. And remember when we did those long, nasty median problems that had like a million numbers all organized in a frequency table? And we were like, we are not going to list out a million numbers. Let's just break this list in half. Where would the halfway point be? Do you remember that we kept referring to the median as the halfway point in a list?
Mm-hmm.
Okay, so now I want you to think about if I have a long list of numbers, I break it in half. Of course, the half would be the median. Okay, but what I'm saying now is I don't want to just break it in half. I want to break it into quarters. If I say I want to break something into quarters, what am I saying?
You're going to break it into like fourths.
4 equal pieces, exactly. So it's already in half. So I would just have to half it again, okay? And that's exactly what it's going to look like. We're going to have this, we call this the first quartile or the lower quartile. It's like the middle point of the first half of the list. And then this one on this side is known as the third quartile or the upper quartile. And people say, Kate, what happened to the second quartile? Well, the second quartile already has a name. That's the median. Why would I call it the second quartile? It's already called the median. Okay, so I have the first quartile, there's the median right in the middle, and the third quartile. Okay, basically, we're not just going to half our list like we do with the median. We're going to half it, and then we're going to half the halves again. Okay, let's give it a try. Let's give it a try. Okay, so I say, imagine that I asked some students how tall they were in inches, and they answered as follows. There's all my data. First thing I asked you is find the median of their heights. Oh, we've done this before. Help me out. How would I go about finding the median?
You're going to list pretty much the numbers, like in
let's list them in order. Here we go. I'll do my 61, and then it looks like there's another 61 and a 62. Oh, I missed one, guys.
67.
Yeah, no, I missed a 58.
Oh yeah, we're doing least.
We have a really short person in the class. Okay, 58. I shouldn't say really short because there's people much shorter than that. But for this class, a particularly short person. Okay, 62, and then I have a 63, and let's see, a 64. A couple of people are 65 inches, and then 66, 67, and 73. And as usual, I'm going to go back and count to make sure I have all the numbers, because when you're taking your GED, you won't be able to cross off the numbers on the screen. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, cool. I got all my numbers. So which one would be the median? How could I get to the median? Well, if I did one off the front, one off the back, one off the front, one off the back, this list is short enough that I could just pretty quickly locate the median of this list. And I would see that the median is 64. Okay, so we're used to that, right? So what I want to tell you is finding the quartiles is the exact same skill. It's the exact same skill. But what you're going to do is you're basically going to look at the left half of the list and the right half of the list, and you're going to do that process over again. So let's find the lower quartile, also known as the first quartile. Look at this left half of my list on the left of the median. Which number is in the middle of this list?
61.
Exactly. One off the front, one off the back, one off the front, one off the back, and the first quartile then would be 61 inches. So then let's find the, ooh, I did this wrong. It's not the second quartile. Let's find the third or upper quartile. Fired, Kate. Typo in your PowerPoint. That's what happens when it's the first time you've used it. Okay, we're going to find the third or upper quartile of their heights. So then help me out, ladies. Where would I find the third or upper quartile?
So 66.
Exactly. One off the front, one off the back. Again, I'm working with the right-hand list, and I get 66 inches for the upper quartile or third quartile. Let's take a look at how that is going to appear now on a box and whiskers plot. So I just have a little diagram up here to help you remember that we need to have that number line in our little box and whiskers, and then what each one of these things represents. The lower extreme, that's the minimum, right? We have the lower quartile, median, upper quartile, and our upper extreme or maximum. Okay, so we're going to do that. Now it says use your data from the last slide to create a box and whiskers plot. I asked some students how tall they were, and they answered as followed. And we had already figured out the median. Can you guys look back at your notes since I can't flip back to that page? What did we decide the median was of this list?
64 inches.
64 inches. We also figured out the lower quartile. What did we say the lower quartile was?
61 inches.
61 inches. And we figured out the upper quartile, the third quartile. What did we say that was?
66 inches.
66 inches. Great. That right there makes the box. These three pieces of information make the box. The median, the lower quartile, and the upper quartile. Okay. So I am going to give myself a number line to go over. And I know that my number line has to have at least from 58 to 73 on it. So let's see, 58, 60, 62, 64, 66, 68, 70, 72, 74. Maybe I'll go right before it. Okay, I'm just labeling my number line right now. This is not too exciting, and I don't care if you go by ones. Sometimes students are like, can we do that? You're going by twos. Yeah, guys, because I'm too lazy to label every number, so I'm doing every other. So let's get the box above my number line, okay? So again, the median is a line in the middle of the box, but the box actually goes from the lower quartile to the upper quartile. So I need a box that goes from 61, so somewhere between 60 and 62, to 66 inches. And there's my box. And I'm gonna have to erase some of my work over here. Now I gotta put the middle line in my box, and it should be at the median. And you guys had told me that the median was at 64, and it would help if I used a pen instead of an eraser. So there's my median height at 64 inches. And then my whiskers show me my max and min, so my numbers on the outside. So let's see, my minimum height in this particular class is 58. So that kind of made for a little bit of a short whisker on that side. And my minimum, or my maximum, I mean, is, well, what's the highest number in this set? 73. Way out here. Longer whisker that way. Okay, is everybody cool with that?
Yep.
Now, as usual on a graph, if I was really creating this, I would want a title. So I'd probably say something like it's height of GED students. And I would want my number line labeled so I knew what it was. And I didn't really leave myself room for that. But it might say like height in inches. And so I would know what was going on. But here is pretty fair example of a box and whiskers plot. Now, I really, really need to point out to you that we ended up splitting the data. So this little piece represents a quarter of my students. That first quartile is a quarter of the students. The length doesn't tell me anything about the number of students. It tells me how packed together the scores are. So this is another quarter of the students here, from the first quartile to the median. And then another quarter of the students would fall here, from the median to the third quartile, okay? And then finally, the last quarter of the students is all here on that last whisker. So there's an equal number of students in each one of these groups. We're used to frequency bars. We're used to the length telling us the number of students. Here, that's not what the length is telling us. The length is telling us how spread out those students' ages are. So each one of those pieces, regardless of whether they're short or long, has the same number of students in them. It's just if it's short, we got their ages all packed together. If it's spread out, their ages are more spread out.
One of my questions.
Yeah, and that's kind of hard to wrap your mind around because we're used to the length of the bar being the frequency. And that's why I wanted this one all by itself, because it's a really different way to look at it. And we're going to have a short class today, which is probably good considering, like I said, although these could show up on the GED, they're not super common. Okay, so this one, I actually found a way to make my own box and whisker plot. Yes, because I was struggling today to find Creative Commons images that didn't have a copyright on them. This one says, the box plot shows the ages of students in Kate's Prescott Morning GED class. First question, again, the GED is an interpretation test. It's not like a make a few graphs kind of test. So let's interpret what we're looking at. Number one says, about how old is the youngest person in the class? Any thoughts?
Like 17.
Zareni says like 17. And what were you saying, Maricela?
16.
Like 16. Now I said the word about, so 16, 17, that sounds like we're about in the same range. So you could both be totally right. Where did you guys get that number?
Because that's the youngest that they can take the class.
Yeah, the youngest is going to be the minimum value. So it's going to be that left whisker. Wonderful. Good interpretation. 16, 17. It would definitely be multiple choice if it was on the GED. Then I bet you'll be cool with number two. About how old is the oldest person in the class?
73.
73. It must be my Prescott. Oh, no, I said it was Prescott Morning. I've had people in their 70s in my Prescott Valley, not my Prescott yet. So I must have been making up some data. Okay, so about 73. And again, we see that from that max value, of course, appears to be somewhere over maybe 72, 73. Easy, right?
Mm-hmm.
So what is the median age of my class?
35.
Oh, what did you say, 35?
Because it's the medium of 70.
Careful. The median is visualized on this graph. I don't just want the middle of 70. I want the middle number in my list, and I actually mark it. There's no marking right there above 35. What is it marked with? How can we find the median? The median was marked by the line in the middle of the box. I'm going to say that again. The median is like the second quartile. So if you have minimum and maximum, each one of these, this first quartile, second quartile is the same as median, and third quartile.
20.
Yes. It might feel really wrong, but it's 20. That means there's, you know, even though this line is really skewed, there's a lot of line off to the right. You know, the middle student in my set is 20. And that's what I was saying. These graphs are really hard for students to interpret because they're used to frequency graphs. They're used to thinking of long meaning lots, and long here doesn't mean lots. Long here means spread out. Okay, so then what does short mean? Short doesn't mean little. Short means packed together. Okay, so let's look at question number 4. So median is 20. Question number 4 is the question that screws students up the most with box and whiskers plots. This concept. It says most of the students in my class are in which age range? And I'm going to just kind of erase my graph here so I can mark all over it. Most of the students in my class are in which age range? Well, what students want to tell me is they want to tell me all the time that this here is very, very, very long. So most of the students are there. But I can't say it enough times. Length doesn't represent frequency on this kind of a thing.
No.
So what does it mean? Well, remember we said this is the first quartile, that's the median, or the second quartile if you think about it that way, and that's the third quartile. What does that mean? That means a quarter of the students were right in here.
So it's 20 to 25.
Yeah, exactly. A quarter were right in there, and a quarter were right in there, and then the last quarter of the class is really spread out. Okay, so Maricela says, so 20 to 25? I don't know. Let's take a look, okay? So the first age range says 16 to 20. Let's take a look at 16 to 20 on this graph. So 16 to 20. Do you see that that is 2 quartiles I'm spanning there? That is the first quartile and the second quartile. That means half of the class is in this range. That's everybody before the median. Does that make sense?
Yes.
Okay. Now let's look at 20 to 25. 20 to 25 starts at that median line, that middle line, and goes to the third quartile. That's only a quarter of the class. And then same thing with because that was 20 to 25. Same thing with 25 to 75. 25 to 75 is a huge range, but we only have 1 quartile here. Third quartile to the end of my list. So it's like the 4th piece of the 4th group. The 4th, if you think about it that way. So this is only, again, a quarter of the class. So it's actually the 16 to 20 that has the most students in there. Why? Because I packed 2 quartiles into that range, or I shouldn't say 2 quartiles, 2 quarters of the class into that range, a whole half of the class. It's mean though, isn't it? It's exactly the opposite of what you would feel or what you would think, based on the other graphs we've been looking at. When it's spaced out, it means the numbers are few and far between. When it's short, it means the numbers are really packed together. Okay, so I had an interesting time. This was one I did find off of a Creative Commons. It wasn't a copyrighted graph, so I could use it. But when I went to read it, I was confused. So let's see how you guys do with it, okay? So just looking at this box plot, also called a box and whiskers plot, what is being shown to me on this box plot?
It's showing size of U.S. states in thousands of square kilometers.
Absolutely, and it looks like Serenity did well to read this little information here. It shows the size of U.S. states in thousands of square kilometers. So number 1 was not my problem. Number 1 was pretty simple. So let's go take a look. It says, number 1 says, about how big is the largest state? And I did say about, so you can approximate, ladies.
It could be 150,000, it says, maybe, or 1,500.
Yeah, so starting with this, like right above here would be 1,500. It's definitely more than 1,500 something. We'll talk about the something in a second, but definitely more than 1,500. Let's see the spacing. It looks like there's 100 between each one of these, so 1,400, 1,500. So I'd say 1,600 would be about there.
Right.
So that's not quite 1,550. I don't know. Shall we call it 1,520?
Yeah.
So I'm going to write that down. But I love that I heard you saying thousands, because you noticed that it said that this land area is in thousands of square kilometers. What does that mean? That means my 1,520 is going to show up in the thousands place of my number. So I'm going to come in and put in 3 more zeros so that 1,520 is in the thousands place. Does that make sense to you?
Yes.
Now, some students really struggle to read that number. Why? Because it only has one comma out of, it would need another comma. After every 3 numbers, we put another comma. So we can see that's a really big area here. This is 1,520,000 square kilometers. And I'm too lazy to spell square kilometers. I'm going to abbreviate it like that. Are you cool with that? I'm not saying square my number. I'm saying I'm too lazy to spell square kilometers. So about how big is the largest state? Super duper large. And again, we had the word about, so we approximated. And thank you so much for not getting fooled and not just writing 1520. That's what most students would do because they wouldn't pay attention to this at all. That's in thousands. Okay, is that good?
Yes.
But if you didn't pay attention to that, okay, if you were the student who wrote 1520, don't feel bad. Hopefully number 2 would help you catch yourself, because that's actually how I caught myself. I took a look at number 2 and I was so confused. Okay, so let's look at number 2. About how big is the smallest state? Now I want to know about the smallest state. And I looked at that graph and I said, the smallest state is 0 square kilometers? What? I had to go Google on the internet to realize what was going on here. But it does say about, so we can approximate, ladies. So it's really close to 0, but guess what? I don't think there's any state that doesn't exist. Okay, like, so it's got to be some number, but we could do an approximation. I don't know. What do you think? Way closer to 0 than 100. What are you thinking?
100.
It's not large, but she's saying it's 100.
Well, 100 would be right here.
Mm-hmm.
I see what you're saying. Are you saying 100, just straight 100, Maricela?
Yeah.
Okay, so not 100,000. Yeah.
Yes.
So you're actually pretty close. I looked it up. It is about 1,000 square kilometers, which means it's 1,000. So no wonder this graph looks like it's at 0. It's at 1. You know, 1 is so much closer to 0 than it is 100. You wouldn't be able to tell this on this graph, but what you would have is a list of multiple choices. You might have one that said 1,000, one that said 10,000, one that said 100,000. You ought to be able to see that it's way closer to 1 than 10 or 100. About how big? I don't know. It's real close to 0. And I only know from Googling that it's just 1,000 square kilometers. Okay, so definitely wanted to do that one because I think if I saw this on the GED, I might freak out. Shoot, I freaked out. I wasn't even looking at the GED. So then number 3 says, what is the median size of US states? And again, it would be about, I'm sorry, I forgot to put that word in there, but we're reading it off of a not very exact graph, so you're only going to be able to give me an approximation. But let's find the median size of US states. What are you thinking?
150,000.
About 150,000. So Serenity is seeing, let's mark what she's looking at, y'all. This line here represents the median coming down. And Serenity, you think that looks like perfectly in between 100 and 200, no closer to either one of them?
It could be to 100, but
maybe a little closer to 100. So maybe I'll say 140,000. Just come right in under 150,000, because I can definitely tell it's just a little bit closer, not a whole bunch. Again, if it would be multiple choice if you're on the GED, so don't stress that. That's not a big difference on this particular graph. And it's 140. It says in thousands, so we'll make that 140 at the thousands comma and add the zeros afterwards. 140,000. So then number 4, I told you that a box and whiskers plot gives us a visual representation of range. So number 4 says, about how much does the size of US states range in square kilometers?
So it would be like the 152,000, and then we would take away the 1,000.
Yes, exactly. We would take that max value. In this case, it was, careful, 1,520,000. And we would take away, you're right, the 1,000, the minimum value. So we're looking at about 1,510,000. Again, these were all approximations. So, but yes, that would be the range. Nice job, Serenity. Okay, then let's look at number 5. Which of the following is most accurate? That sounds like the science or social studies test. Which of the following is most accurate? Most US states are smaller than 100,000 square kilometers. Most US states are between 100,000 and 200,000 square kilometers. Or most US states are greater than 200,000 square kilometers. Man, it's that issue with length of bar again, isn't it? It's the quartiles. Each one of the quartiles marks the end of a quarter of the data. So that means that from here to here, we have 25% of the US states, or 1/4 of the US states.
Right.
And then from here to here, we have the next quarter. I know it's small. They're all shoved together. They're all similarly sized. We have another quarter of the states. And then from here to here, we have another quarter of the states. And then from here to here is the other quarter of the states. Why is it so spread out? Because darn it, Alaska and Texas. You're way over there making my line long. Not a lot of states, just a couple of really large ones. So then which one of the following is most accurate, do you think?
100,000 to 200. I don't even know how to say the numbers.
200,000. No, you were saying
Yeah,
it perfectly.
200,000.
That's exactly how you say it. You say 100 and then you read the comma, 1,000. You say 200 and then you read that 1,000 comma, 1,000. Good. So very nice. You're absolutely right. We had pretty much 2 quarters. We had a whole half in that grouping, even though it's short, it's small. And I know I'm pounding this into your head, but that's because it's one of the most common misconceptions about these kind of graphs. I think we're almost done, but I just wanted to show you that we could have more than one box and whisker plot on the same graph. Okay, you know, like the GED likes to be complex, so I wouldn't want you to freak out if this showed up. First of all, I didn't give you any information about this graph, so you're gonna have to go find it by looking at the graph. It doesn't even have a title. What a slacker. This graph should have a title. Can you guys just look at it for me? Try to figure out what's going on. What might be an appropriate title to this graph?
It looks like it's a stocking company.
We're selling stocks for sure.
Yeah.
And it's by what? What's on the other axes?
By groups.
Yeah, by company in this case. So it looks like we're comparing some stock sales by company. Does that make sense, ladies?
Yes.
Yeah.
Okay, so I think I'll call it stock sales by company. That sounds good. So A says, what was the range of stocks sold by company C? So I just want the range of company C. Any ideas?
It'd be like 2,500, I'm thinking.
You're thinking you have a range of 2,500. So tell me where those numbers came from. Where are you looking, my dear?
Well, I took the 1,500 on the pink shaded side.
Careful. Max and min is what you want for range. That's the first quartile. That's the first quartile. Doesn't come into play with range. Where do we find the max and min on a box and whiskers plot? The max and min are the end of the whiskers. The end of the boxes are the first and third quartiles. So we have our min and our max. So I still have to find the range. I mean, range is found using max and min, but they're not synonymous. What will I do with these numbers here?
Why don't we take the pretty much like the max minus the minimum?
Absolutely. Good thing. I want the difference between the max and minimum. So a real easy way to do that would be to take the max. What would you say that max is?
4,500.
I think it's a little beyond that, huh?
Yeah. So maybe like 4,700?
Maybe. Again, we're only able to approximate off these kinds of graphs. So 4,700. Now be really, really careful. Did you read the labeling on that number line that I'm pulling numbers off of right now?
Number of stocks sold in thousands.
In thousands. So that's 4,700 thousands. You're gonna have to put down a thousands comma and give yourself 3 zeros like 1,000 has. And now you're thinking, well, that's not 4,000, that's 4 million. Yeah, 4,700 thousands is 4,700,000. And that's kind of weird for students to wrap their brain around. Okay, that's the max. And from that, I'm gonna subtract my minimum. What is my minimum?
100,000.
Well, it's 1,000 thousands right now, but I'm not used to talking about 1,000 thousands. That's not how we say things. So let me write it down before I try to pronounce it. Okay, Serenity? So there's my first 1,000, and I'm going to put that in the thousands place by putting a comma and 3 more zeros. As we know, every 3 numbers, we get another comma. So 1, 2, 3, comma, 1, 2, 3, comma. That's actually a million. 1,000 thousands is a million. Do me a favor. Pick up your TIs. You guys got your TIs for me?
Yeah.
Multiply 1,000 by 1,000. 1,000 thousands, right? That means 1,000 times 1,000. Do it for me. What do you get? So 1,000 times 1,000.
Yeah, that's a lot of zeros.
Yeah, it's a million. 1,000 thousands is a million, okay? So it's the number of stocks sold in thousands. I've got 1,000 thousands. Okay, everybody cool with that?
Yes. Hard
It's
to
weird, isn't it?
read about the money.
Yeah, it's not us buying and selling millions of stocks, is it? Some a big company out there. Okay, so now we'll subtract these number of stocks sold in thousands. We'll see that the range is about 3,700,000. And again, I can't stress it enough. This was an approximation. So internet, if you got 3,600,000 or 3,800,000, please don't yell at me. We are approximating off of a not exactly accurate graph. A little ugly. So we can't find the range until we can locate the minimum and maximum. Okay, let's look at B. What was the median number of stocks sold by company A? I want the median from company A now. Help me out. Where would I find that?
Isn't it like in the middle of the box?
It
That
is.
line
The
drawn?
line in the middle of the box is the median. And which box are you looking at? Serenity?
I think it's just a line drawn in between the pink and the green.
Yeah, you're absolutely right. I'm just wondering which box we're looking at here. Overstate the obvious for me, my dear.
The last one.
Yeah, the
Yeah, the
bottom
last
one.
one.
Yeah, company A. Wonderful. Okay, so right about here, that's my where I'm gonna say the median is. So anybody care to guess where that is?
1,800,000 maybe.
Maybe 1,800,000.
Thousand.
Yes, nice. So again, Maricel is saying she's somewhere between 1,500 and 2,000. So she's thinking it's about 1,800. And then she did the work to say that's 1,800 thousands. So she put that little thousand comma down, dropped 3 more zeros, so that could be 1,800 thousands or 1,800,000, same difference. And again, I'm approximating. You can see apparently I really like to hide numbers in the units on the graph. So does the GED. So watch that, read those, make sure you know what they are. I looked at a graph the other day where somebody forgot to label it. They made a graph. It was a fun one. I think it was from a newspaper, but I have it in my in my misleading charts and graphs PowerPoint, and it's a great one. But it has eagles. It's about eagles, and then it has all these decimal numbers like 0.01, 0.02, 0.03. And it just says eagles instead of saying eagles in thousands or eagles in millions, it's talking about population, but it just says eagles without telling us what those numbers represent. And I just imagine all these pieces of eagles all over the place. It's just 0.01 of an eagle. Just, I don't know what it is. It's like a claw just flying through the air. And I was like, I need a number here to help me understand this graph. So C says, which company holds the record for the highest number of stocks sold?
I will say no, company C.
Company C. Okay, so where on the graph do you see the highest number of stocks sold by company C?
There's the biggest, even the pink and the green.
Careful. I mean, you're right that it does have the biggest of the pink and the green, but look at what I'm asking you. The record for the highest number. The highest number, well, that's a synonym for the word maximum. Do you see why I'm saying this isn't really about the box and whiskers? This is more about the interpretation, okay? I'm looking for the max, the company with the max, the company with the highest maximum. Does that make sense? They hold the record.
Yeah, now say the company.
Which company is it?
D.
D. How'd you know that, Maricela? What about company D told you that they had the highest, they had the record sales?
So the Whiskers are bigger.
Yeah, their max stretches out further. Comparing the 4 maximums. If we're looking for the record of the highest number of stocks sold, we're looking at their maximums and comparing them. And definitely D's goes the furthest out, the closest to 5,000 here. So it's definitely company D. And we can see it's really about interpretation here.
I think with the interpretation, students forget about the whiskers on the end that are included in the graph. So that's why the interpretation goes back into the boxes.
We keep looking at the boxes. Yeah, so that's part of just knowing what a box and whiskers graph is.
Basically.
So then D says, which company will probably sell the most stocks on average? Now, I'm saying probably, so we're making an inference off this graph, but we're looking for who sells the most on average. Now I might be looking at the boxes, because now I'm looking at, towards the middle of their list. Does that make sense?
Mm-hmm.
So who do you think might sell the most stocks on average?
It probably would be company C.
Yeah, that's what I'm going to say too, Serenity. I would think, and now I'm making an inference. I don't really know anything about averages based on a box and whisker plots. I know about medians and I know about distribution. But what I see here is I see a lot of my scores of the whole half of the list falling into that high range. And even my low scores are higher than some of the other low scores, you know? And so, yeah, I'm going to go ahead and say on average, company C probably sells the most stocks. Okay, so then this one is totally just your opinion, guys. I just wanted you to kind of analyze this graph now that we've looked at it so closely. Which company would you use? If you were looking at this, you were deciding, you know, I want a company that sells a lot of stock. Which company would you use?
I will use C.
C.
You would use C on average. Yeah, they might not have that record, but it looks like overall they perform well most of the time. Okay, cool. I probably would too. Wonderful. Ladies, this is all I have for you today. It's not a long class because, like I said, it's not a huge part of the GED, but I did at least want to give you a taste of it. Thank you for joining me in virtual GED class. Join us next week when we look at finding mean, median, mode, and range from all different charts and graphs, every kind we've learned. It's going to be a great mixed review of all the concepts we've done so far, and it'll propel us forward in our data analysis unit. Okay, so see you next week.